Hello, everyone, and welcome to York Universe, the Astronomy and Astrophysics radio podcast, written, presented by the students, faculty, alumni, and friends of York University. You'll find us now wherever podcasts are distributed. I'll be one of your hosts this evening. I'm Mary Helen Armour, and I'm joined by Dr. Jeremy Webb from another professor at York University. We are broadcasting live from the Allan Carswell Observatory located at York University in Toronto, Ontario, Canada. York Universe broadcasts live every Monday night at 9 p.m. local Toronto time, or Tuesday morning at 2 a.m. UT or 1 a.m. UT if it is daylight saving times, on YouTube at York Observatory in concert with our online public viewing program run by the Observatory team. Right? To navigate the live show or find out more, you can check out the Observatory website. That is at www.yorku.ca/science/observatory. And you can follow the links to the online public viewing. And we have a live chat going while we are doing the podcast. Right? For any questions or comments you have on this or any other past shows, or if you have suggestions for a future topic you'd like to hear about, you can always send us an email at observe@yorku.ca. You can also connect with us on Instagram with the handle at YorkU Observatory, and on Facebook at the Allan I. Carswell Ops. Right? All of our programming is free, but if you'd like to make a donation, please see our website. Okay? We will be monitoring the chat room for any questions about either the images we're showing or about what we're talking about in the podcast. The current weather right now is hot and muggy but clear, so hopefully later on during the broadcast we will have some live images coming online. Okay? So for this show today, I'm joined by Jeremy Webb, and given the time of year it is, we're going to spend a little bit of time talking about the summer solstice. It just happened this past Friday. Most people tend to think of the solstice as, okay, it's the longest day of the year, we have the most daylight. But how we actually describe it is when sort of the Earth is at its maximum tilt, so the sun appears at its most northern sort of point in the sky. It would get sort of the highest in the sky above the southern horizon. And the exact definition is when the sun actually touches the northern tropic, which is at 23.5 degrees of latitude. And this happened this past Friday at 10:42 Eastern Daylight Time. Right? So there is actually a very specific time when the solstice is, and this applies to the winter solstice, and that applies to the equinox as well. There's a very specific time at which this occurs. It's not just a day. It's not a particular sunrise. It's actually a specific point in time when the sun would seem to be directly over the tropic line, right? And in fact, the word solstice is Latin in origin. The word for sun, of course, in Latin is sol, so that's the first half of it. And it also has the Latin word for stand still, sistere, built into it. So solstice refers to when the sun sort of stands still at its highest point, right? You get solstices actually twice a year. You also have the winter solstice, and in the winter solstice, it's actually over the southern tropics, so below the equator. But for those of us here in the northern hemisphere, it'd be when the sun sort of reaches its sort of lowest point in the sky. Okay? And there's a lot of cultures and everything that have marked solstices. They have been an important timekeeping. They're often sort of into the growing season, and they help you mark sort of how much time you might have left before you might need to harvest your crops. But the thing to remember is, although we can pinpoint it very accurately in time now, a lot of these monuments, and Jeremy's going to talk about a couple of them in a minute, actually sort of marked a point of maybe few days, maybe even as much as a week in time, where the sunrise would occur at a particular point in space relative to the monument. Uh, it's sort of a mistake to think that all of these ancient monuments were so accurate that you had this one day when the sun rose and there would be the solstice, because what exactly time of day the sun hits the solstice point, it's not necessarily going to have, one single sunrise that shows that way. Although, obviously, we tend to think of it that way now. That's maybe not quite how the ancients thought about it. But Jeremy, I think you looked into a few ancient monuments that had some relationship to the solstice.
Yeah, no, absolutely I did. Once I found out we were doing the solstice show, I dug in a little deep to this. And I learned a lot, and I learned that it's something that's still celebrated at a lot of these monuments still today. So for example, at Stonehenge, you can actually, most of the year round, it's closed off to tourists. And then, if you've been to Stonehenge, not on a solstice, there's ropes that's roped off, and you gotta stand far away, and you kind of get a good look at them, but you're not too close. But apparently on the summer and winter solstice, they let people go right up, right into Stonehenge and touch the stones, and it's actually a big celebration and a big party. And one of the reasons this is true is because Stonehenge was part of it anyway, was designed such that the sun rises directly over one particular stone on a sunrise, I guess, near the solstice, to kind of go in line what you said. Um, and it creates a particular shadow that aligns with two of these other pillar stones, and it creates this big kind of U horseshoe shape that opens up towards the sun. And so the fact that it has this special significance on this day is one of the reasons they open it up for people to celebrate the solstice and get right up close. But yeah, Stonehenge is just one of many. A couple of the other really interesting ones I came across was a Mayan pyramid in Mexico, and it was constructed in such a way that its axes are oriented toward the rising sun at the summer solstice and the setting sun on the winter solstice. Um, and then even more so, it seems like this whole pyramid was maybe had the sun in mind, because on the equinox, which you also mentioned, the shadows and the sunlight combine to make a serpent's body shape on the pyramid that ends at the bottom of the pyramid, where there's then a serpent head carving. So the shadows and the sun were made to line up with this carving at the bottom of the pyramid. Um, and then another one that I kind of got a deep dive into were medicine wheels, which are these sacred structures that hold ceremonial and spiritual significance for indigenous peoples of North America. And there's only, like a few hundred of these that are kind of still known in North America that have been preserved. And what they are, there's these the set of two concentric circles made out of stones, with then lines radiating out from their center. And that kind of makes the whole wheel, but then also amongst the wheel are these stacks of stones, some outside, some inside the wheel. And the stacks are very specifically placed in specific locations. So the solstice sun will rise between two particular stacks and set behind another. And these were just three examples, three of many that I found that really show these different cultures, different civilizations, some present day, some quite ancient, just really had a strong connection to the sun and the sky. And without the modern technology that we have, worked really hard to predict its comings and goings and its behavior, and understand it as best they could. And I thought that was all just really amazing. And I know you have experience with your history of astronomy course that goes beyond my deep dive this week.
Yeah. Well, it's just I've always found some of these things fascinating, and you're like, the interesting thing is they talk about Stonehenge, um, and it's probably one of the more spectacular ones in sort of the United Kingdom. But these kind of henge type monuments are actually spread all through sort of Britain, Scotland, Wales. Stonehenge is just the most spectacular example of it.
Right.
And most of them are all sort of roughly aligned to various points with the sun. Not all of them. but the sort of henge building seems to have been a period of time when they built, like quite a number of these monuments, and a lot of them were all based on these solar alignments and sometimes alignments to the moon and other stars. But it's kind of it seemed to have been a very common practice in that time period because this is how they kept time, right? People
Hmm.
couldn't count, people didn't write down things. So if you were trying to figure out like when to harvest the crops and do these kind of things, you use these kind of monuments. I mean, obviously, it had a very strong ritual component. They do think Stonehenge is also a cremation, has cremation burials in and around the stones, but clearly the timekeeping aspect was very, very important. And this is true of a lot of monuments. The interesting thing, though, is most of all of these ones are going to be a little bit further from the equator because once you get close to the equator, the solstice doesn't stand out that spectacularly. So when you see these solstice monuments, they're all sort of a little bit north or, well, some south of the equator, but there's not as much landmass south. Uh,
Right.
so you have like the Stonehenges and the Mayan pyramid and the medicine wheels, but these are all a little further north. If you get close to the equator, these don't exist because the solstice doesn't send out because the day length doesn't change that much, right? So the solstice is very much sort of a northern culture type of observation, which I always found kind of fascinating that, like the different cultures, depending on where they were on the globe, use the sky in different ways, right?
Yeah, absolutely. And I think what you highlight too is that, there's all these northern cultures or whatnot, and they're all different parts of the world, but they all were fixated on the sun or the moon in some way. Everyone was still looking up and connecting themselves to that, no matter where they were from.
Yeah, because everybody could see the sky, and if you didn't have TV and you didn't have social media and you couldn't read and you couldn't write, well, what did you do? You watched
Right?
the sky, right?
Yeah.
And although we think of it as highly technical, I mean, I I haven't done this myself, but I've known some people who've done it with their classes, is just even sticking a simple stick in the ground and marking every day sort of where the sun rises from. You can kind of track it over the space of a year as to sort of the pattern in the sky, and it keeps coming back, right?
Mm.
So it's a fairly simple exercise to do. You just have to take the observations for long enough to see the pattern emerge, right?
Yeah, and I think too, what's interesting is, there was these are back times when, we kind of thought the Earth was the center of the universe, and people still thought maybe the Earth was flat. So there wasn't even an amazing, understanding of the motions and how everything behaved. Yet there's still this attempt to understand it and mark it and map it. And I think it'd be interesting too. I think part of it would be scary. Like why are things changing so much? Something new, like, there's supernova events in the 1600s, the 1100s, like a new star appears in the sky, and you don't have an understanding of the life cycles of stars and supernovae and deaths. I think those things they would be a little scary. A comet shows up, you're like, what? This was not here this time, yeah, last night.
Yeah. When
That would really mess with people's view of the world, I think, or view of
yeah,
the.
and I think that's part of the sort of ritual reasoning behind some of these monuments is it's a bit of an attempt to predict the future, right? Like we can tell you where the sun is going to come up. And that's really in some ways the start of astrology is like, okay, if we can, use our monument and tell us, okay, the sun's rising here, this is the longest day of the year, and now the days are going to start getting shorter. It to them, it's almost like, I don't know, magic power to be able to control that. And this is, I think, really where astrology starts getting tied in because, okay, if I can predict the future with one thing, how far can it take this?
Right?
Right. So,
Yeah, and it is the first step in science, right? Like just making observations and predictions. You don't necessarily need to know the Earth goes around the sun or the Earth's axis is tilted, but if you mark out those observations and you keep track of it long enough, yeah, you can make pretty decent predictions when the sun's going to come up tomorrow if you've been marking it for a whole year or something like that.
yeah.
So yeah, and which ends up being a first step in science, and then the kind of data that you've used to then come up with an actual theory.
I mean, and that's where the solstice also had the practical, because of course uh, you have timekeeping, which is, what some of these monuments relate to. But that was also how Eratosthenes sort of figured out the size of Earth. Because there was a location he was located in Alexandria. He was at the Great Library. So this is around 400 BC. And at the time, of course, they knew the Earth was round by then. Okay, Plato had figured out, Plato and Pythagoras had sort of, Pythagoras in particular, had sorted out, yes, the Earth is round. We knew that, right?
Mm,
So Eratosthenes figured out the size of Earth, like what the diameter was, because he knew on the one particular day that was the solstice, there was a location in a city called Syene where the sun shone directly down the well and it didn't cast a shadow. And where he was located in Alexandria, there was a shadow cast. And so he figured out what the distance between these two cities was. And so from the length of the shadow in in Alexandria and the lack of a shadow in Syene, he actually managed to work out what the circumference of Earth was. And he was reasonably accurate. We don't know exactly what his number is because he used a distance unit called stadia, and we aren't quite sure exactly how long that was, but we do figure he was fairly accurate to within a few percent. So,
wow.
400 BC, or yeah, somewhere around there, we knew how big the Earth was from this work at the Alexandrian library. I may have Eratosthenes. I may have the year from B. I may have the year not quite right. But it was in that sort of, sort of around 300. I'm probably getting the not. I
Mm,
probably haven't got the number quite right, but it's around 300 BC that he worked this out, working at the Alexandrian library. So we've known that Earth was round, from observations of the sky, and we've also known the size of Earth from using the solstice to help us figure out, and so we've known roughly what the size of Earth is for a very long time.
wow,
And this is
yeah,
how the solstice becomes useful, right?
absolutely. Absolutely. And yeah, just having those numbers, you can think within that inspired exploration and stuff later, you quickly have a sense of, well, this amount of Earth that I am familiar with, that I can see, or that I visited, is such a small fraction of its surface area. So there's more out there. Or you can strongly suspect there's more out there.
I mean, later explorers, even like Christopher Columbus and stuff, they talk about, oh, well, he was trying to prove the Earth was round. Well, they already knew the Earth was round. So that's just an urban legend that he was trying to convince people it wasn't flat.
Right.
The scientists and stuff knew it was round. And this is where how he could estimate like how far he'd have to travel to go the sort of long way around to India to reach those trade routes, right?
Hmm.
So it's like I said, something as subtle as measuring the solstice led to all these kind of other activities, which is sort of like the simple starting points are sometimes the really, really important ones. Mhm. So,
Yeah, and you mentioned like Columbus and traveling and sailing, just not so much the solstice, but the night sky and navigation in general was just pivotal, and to be able to sail and travel at night, until we had more advanced ways of traveling. There's I've read about how ancient Polynesian cultures, that there are some islands that even closer to present day with proper GPS and tracking technology, there's some islands that only the indigenous can travel to, just based on their knowledge of the stars, and star stories handed down from generation to generation is quite amazing. And the fact that accuracy can be gained just by measuring, looking at the sky, I find to be just amazing.
yeah, I mean, we've kind of lost some of that because we don't pay attention to it other than, well, it's annoying if, I want to go to bed early and, the sun doesn't set until 9:30 or 10 o'clock at night and it's
Right?
still light out, like at this time of year. Or if you go far enough north, of course, when you hit close to the solstice, the sun never sets, right?
Right?
I mean, that was sort of weather, the Government of Canada weather site talking about sort of what cities were now in had the midnight sun and where the sun was up, and how many days it was between sunsets because of, you're close to the solstice. So the top of Earth is pointing towards the sun, and it doesn't set. It just goes round and round and round.
Right?
So that's,
And
it's
even if
kind
you're a
of
little farther
interesting.
south, even if you're a little farther south, you're still going to bed with the sun up and waking up with the sun up.
Oh yeah, it only sets for a couple of
Right?
hours,
Even
right?
if you're not part of the 24 hours a day, like it's still always there for you.
Yeah. And
Yeah.
it's sort of like but and unless you've lived in different parts of the world and paid attention, you don't realize that as you go from the northern hemisphere, where the solstice has this really long day, if the sun even sets at all, if you're far enough north, and the closer you go to the equator, it just disappears because near the equator, sunrise and sunset are always about 12 hours apart.
Right?
Right?
Yeah.
So it's one of these fascinating things. And so it really sort of speaks to even how regional astronomy could be, because the solstice in England, and going south, like even to sort of places in Africa and Egypt, like where Eratosthenes was working, it's not the same, right? The length of
Mm.
the day is not the same. So,
Yeah, no, it's quite amazing. I remember when I traveled once for work to Australia. And I went out for a run at night, and I was about halfway through my run, and something was weird, and I just remember just looking up, and I really didn't recognize the sky. It was my first time going south of the equator, and I was surprised at how much I, noticed that the seemingly random distribution of stars in the sky was actually different. Things didn't look right,
yeah.
and I was very surprised by that.
Yeah, I mean, and but we're people with like an astronomy background, so we probably pay attention to that. You wonder how many people would actually notice in
Maybe,
this day and
yeah.
age. And
I mean, yeah. Besides a few constellations, though, I don't know how much. I don't know. Maybe it's because I'm a theorist. I feel like I'm not.
I'm not much better. If I really want to remember where something is in the night sky, I still have to whip out my app and check
Yeah,
my
yeah,
iPad. I
exactly.
mean, it's like I said, yeah, I know where the Big Dipper is and the Summer Triangle and
Yeah,
the
yeah, I can
major
pull it up.
constellations, but it's like some other stuff. It's like, yeah, okay.
Yeah, yeah. No, I
What
still
planet
keep an
is
eye.
out tonight?
Pretty sure that's a planet. It's bright and it's not twinkling at this
Twinkling,
point.
and
So, yeah,
it's not a satellite hurtling across the sky.
right. But though then you have then you have observers like many of those on the team here that work with in the Carswell Observatory that really know when things are up in the sky and roughly where they are on a given night.
Yeah.
So it's pretty cool.
But it's kind of interesting because if you think back, probably our ancestors were much more familiar with the night sky and knew where to find things, and you know were very aware of the changing day length and when it hit the solstice and when it started getting shorter. Whereas I think we kind of take it for granted. Like people don't really, I mean, unless you're sort of, I think, in the depths of winter in the middle of the summer right now, where the days are either really long or really short, I'm not sure how much people pay attention to it in this day and age of sort of, electronic clocks and artificial lighting and all this kind of stuff. And you feel sometimes like people have kind of lost something a little.
Yeah, once it's no longer like life or death or
Yeah.
like part of your livelihood, when to plant, when to harvest, it just kind of becomes, hey, if you're interested in it, that's awesome. But if you're not, you can get by
Yeah.
without paying attention.
So, but I
Well, that's
think
why
it's
it's up
useful.
to us to keep inspiring that interest and keep showing people why it's cool.
Yeah.
Yeah.
Well, it's like I said, I think it's good to have a sense of where these things come from and how why is Stonehenge significant and why are these people there? The interesting thing about Stonehenge is the people who are the modern day Druids who celebrate it actually have no connection to the people who actually built Stonehenge.
Oh,
Was it 4,500 or more years ago? The modern Druids only started back in the 1800s. It was one of those kind of like new age sort of movements. And prior to that, the Celtic Druids, they had nothing to do with Stonehenge originally. Like, there's no writing on Stonehenge, so we don't know exactly, to this day, exactly who built it and why. There's a lot of archaeological speculation out there. Uh,
wow.
but they still, I mean, that's the interesting thing. It is such a, it is, it's such a massive monument. Um, it's got this very distinct alignment to the summer solstice sunrise, and on the directly opposite direction, it'll be the winter solstice sunset, because those two are directly opposite in the sky.
Right.
Um, and there are some other alignments too, they think, with Stonehenge, although how much of that is speculation and sort of writing things in. Some of it is undoubtedly there, but some of it's probably a little overdone. Um,
Maybe. But I mean, also, if a few things are aligned with the solstice, then some other things are going to line up by
Yeah.
accident.
And it's yeah, and the monument fits that, but it's
Yeah.
like I said, because they had no writing and there's like no records or anything. We don't know exactly what they built it for. You can listen to all kinds of archaeology and archaeologists, and they have all kinds of interesting ideas. And actually, not even that far from Stonehenge, there's another one just a few miles up the Avon called Durrington,
Okay.
it's an even bigger henge, but it was only built with wooden posts, right?
Oh,
And it also seems to have had those solstice, summer and winter solstice alignments. And the archaeological evidence seems to suggest they did a lot of partying there.
okay.
They found a lot of like pig bones and remains of fires and all kinds of interesting stuff. Um, but
So
that's
there's a
only a few
non-zero
miles away.
chance,
It's kind of like, why would you have the second massive monument from about the same time period so
right?
close by? Um, so it's kind of, like what were they thinking when they built this? I mean, there's the practical of timekeeping, but what was their other sort of, I guess, human cultural experience that went into this? And we'll probably never really know because there's no records, right?
No records. Yeah. I mean, so there's a non-zero chance they could just be ancient crop circles that people just,
Yeah, exactly.
put up, have a little fun, have a party, and then they forget about it and move on. I don't know.
I mean, do you think about the amount of work that would have had to go into raising these monuments?
Well, that's the
Uh,
thing. Like, if they just wanted to keep time or something, they could have done something a lot
Simpler?
less hard. Well, yeah, a lot simpler.
Yeah.
So it's one heck of a crop circle if that's what it is. But
Yeah. Well, I mean, with the pyramids and with the Mayan pyramids, at least they had a writing system, so we have some sense of what they were after. We know what their religion was. We know who Kukulkan was. We
mm,
knew serpents were very important to them. So when you have that particular pyramid with the snake traveling up and down with the
yeah,
equinoxes and the solstices, the pyramid being aligned to, we kind of understand a little bit why, because we know something about their culture, because they did have a written language. Right?
yeah,
Um, and a number of the other Mayan pyramids are also very spectacular constructions with clear astronomical alignments. But something like the medicine wheels or Stonehenge, all we have is this solstice alignment, and you're trying to sort of, I guess, figure out the mystery of
yeah,
why would you do this?
yeah.
So it's probably a mystery that we'll never answer, but it's still kind of cool that, like almost 5,000 years ago we could do this, right?
Right?
Um,
Yeah, that is a long, long time ago, and we
yeah,
have this. Human beings have this
I think
capability.
I think we tend to think because things are far in the past, people were, I don't know, primitives wandering around like, with
Mm,
spears and stone axes, but you could still do some pretty spectacular things. And they know when they were digging out the ditches for like Stonehenge and stuff, they were doing this with like deer antler picks and stuff. So this was a massive amount of work.
yeah,
And
and
yet they
and
did it.
right? Like human beings, like our capability for knowledge, our intelligence, hasn't really changed that much over the last few thousands of years. Yes, we've gained knowledge, but like our brains' capabilities, you could magically transport someone from 400 or 500 BC to present day as a baby, and they could go through grade school, go through undergrad, no problem. So the brain's capability of intelligence is hasn't changed. So there isn't this idea that there's like primitive ancient cultures that just weren't that intelligent is very misleading.
And I mean, and I think that's the value of some of these ancient monuments, and they're displaying, marking the solstice and stuff. It tells us something about, you know, the human experience and just how clever they were at being able to do these kind of things, right? It's so much more than just putting a rock in the right place to catch. the sunrise. There's just so much else behind it. It's kind of fascinating when you think about it, right?
Yeah, like
Now
if you
this
took
is
the
really the origin. This is really in some ways the origin of science.
Yeah, absolutely, absolutely. And I think if you took the average human being from today and transport us back in time, I don't know if I couldn't build a Stonehenge or anything like that. So yeah, it's pretty amazing.
So. All right, we're about halfway through our broadcast. You are listening to York Universe broadcasting live from the Allan R. Carswell Observatory, located at York University in Toronto. You can check out our website for this and many other podcasts and information. That is at www.yorku.ca/science/observatory. Tonight, you are listening to myself, Mary Helen Armour, and Dr. Jeremy Webb, and we have been discussing the solstice, and we'll go in the second half into discussing some more modern topics. Um, and a reminder to all that we will be having our open air Astro Fair sometime this week. If you are interested in attending, tickets are available online at the York Observatory website. We will be doing observatory tours, and we will have a whole lot of interesting booths and activities set up on top of the Arboretum parking garage. This will happen the first clear night from tomorrow night, June 24th onward. So if you're interested in joining us, keep an eye on the weather. There will be announcement by sort of about 9 a.m. in the morning as to whether it's a go or no go. And it will start at about 5 o'clock in the afternoon and run until about 10, 11 o'clock at night. Earlier in the evening, we'll have solar viewing. And then after the sun sets, the telescopes will be set up for some nighttime viewing, which is why we need some clear skies to be able to do all this. So in the second half, we are looking at some of the more recent news and a bit of what's in the sky right now. Probably one of the most spectacular things is the Vera Rubin telescope in the southern hemisphere is now operational. And if you go to many websites, I was on the BBC News earlier, they have it. They have a pretty spectacular image, one of the first ones sort of Vera Rubin has published uh, as the telescope. I don't know. I don't know a whole lot about the Vera Rubin. Jeremy, do you know more about the nature of this telescope and sort of all its capabilities and background?
No, probably not too much more than you. Except I know its plan is to essentially almost every night for the next 10 years map out the entire southern sky. Um, it's collecting just absolutely insane amount of data. The images they released today are just a fraction of the observations and the data that they've come up with. And I know its goal is to really try and understand the nature of things like dark energy and dark matter. All right, and they really want to look at the positions and motions of the most distant galaxies that we can come up with to really understand things about the universe's expansion rate. Is it accelerating or not, or if it is, by how much? And really understand maybe how dark matter, which we know exists because it gravitationally interacts with things, even though we can't see it. Maybe really get a handle on what exactly it is and how it's working, yeah, what is it and why can't we see it, kind of thing. So I know very loosely that's its goals. But in terms of the nitty-gritty behind the telescope, yeah, I don't know as much. I do know just from headlines today that it's literally the world's largest digital camera. Uh,
I mean,
so,
it's fascinating, and like as with so many of these telescopes built in ground-based telescopes built in recent years, they're all on the top of high mountains where
mhm.
they're fairly inaccessible because you're above more of the atmosphere, so you can see better into outer space. I mean, we do have things like Hubble and James Webb that were put into outer space, but those kind of things are so expensive. It's easier to build a much bigger telescope on the top of a mountain than it is to launch one into space. Uh, and like I said, Vera Rubin is in the southern hemisphere, which is interesting because I don't think it's nearly as well mapped as the northern hemisphere.
Yeah, yeah, exactly. So I think having it down in Chile, with just yeah on top of a mountain, really great seeing conditions. Hopefully, it's just going to bring in a wealth of data we haven't really had before.
So, yeah, it's
Yeah,
like I said, it's interesting even looking at some of the articles. I don't know if you've seen some of these. What was it that was published just recently about the potential for a ninth planet that's way out there
yeah,
somewhere, and that's one of the potential things that, Vera Rubin could find if it actually exists. I'm still
yeah.
slightly skeptical on that one, but yeah.
Well, so there's this great video. It's on YouTube, but it's also on the website I was following was the Noir Lab website.
Yeah,
And it shows this great video that I highly recommend anyone checks out if this remotely sounds cool. But I guess, essentially, since the Rubin telescope is mapping the whole night, the whole sky every night, it's really easy to pick out things that are moving. Because, you just compare one night's image to the last night's image, and if something's not in the same spot, it's clearly moving. And it picked up, just in its first night of observations, nearly 2,000 asteroids just in our solar system and they're all in the asteroid belt. So there's this great video of just showing them all moving, and then it zooms out and it shows all their positions. Some are near Earth asteroids, none of them believed to be dangerous. Plenty are in the actual asteroid belt. So I guess the fact that its resolution is so high, it can really pick out these tiny, tiny objects. And so the argument is over the course of maybe a year or two, if it sweeps up enough of the night sky and gets deep enough images, if there's a planet out there, even a small one, it should be something it picks up.
yeah.
So like I said, if it does happen, or if it happens, that would be really interesting. Yeah, I'm skeptical too about Planet Nine's existence, but it'd be cool if Vera Rubin can rule it out or confirm it either way.
Yeah, I mean, I guess the interesting thing about the recent Planet Nine search is it's actually someone who's been involved in like um, real research in doing this, who's suggesting that it could exist based on some of the gravitational disruptions or gravitational effects they're seeing in the outer solar system. So this isn't like somebody, like with their crazy out there theories. This is actually sort of a real astronomer who's been involved in finding other exoplanets who is suggesting this could still
Yeah.
be there. And it's like I said, he describes himself, I'm so bad with names. He describes himself as a bit of a skeptic in the
Right.
whole thing. So he's like, yeah, but
Well, that's the thing. It was always kind of one of those really out there ideas that didn't gain too much traction. But then, like you said, this person kind of came along and said, "Well, I did some calculations, and it turns out there could be something there." And like you said, when it's someone who's credible and it's not someone who's been saying Planet Nine causes global warming and Planet Nine causes
yeah.
solar flares. This is someone who whose work you trust, and it's interesting and. We'll see. I mean, I'm sure everyone probably thought there weren't any planets beyond Saturn for the longest time, and everyone who suggested anything else was
Yeah.
crazy.
Yeah. But it's like I said, the Planet Nine thing is kind of funny because it's floated around so much, and right as Vera Rubin comes online, it pops up again.
Yeah.
Now they suggest this one would go way far out and also be highly tilted relative to all the other planets, so it wouldn't be an easy thing to spot. But Vera Rubin might have the capability to do it, right? So
Yeah.
it'll be interesting to see if it finds another one out there. Um,
Yeah. And it goes with, I mean, so I think for a long time when we think of like planet star system, planet formation, like we kind of had this idea of, oh, everything's nice, everything's on its circular orbits, everything's happy. There's no reason to think there's something way out there doing something weird. But as we find all these exoplanet systems and we start modeling planetary systems, we see that it's likely or it's not impossible that a few other planets did form around our star, and whether it's planet-planet interactions or star-planet interactions, could have kicked them out on funky orbits. So. to find it in no way would break our ideas of planet formation and stuff like that. So there's no reason to think why it couldn't exist, except for the fact that we don't have evidence for it.
Yeah. I mean, it's like I said, the gravitational data is a bit on the thin side. It's certainly a possibility.
Yeah.
I also find the naming of the telescope fascinating because I think this is the first telescope they've actually named after a female astronomer, astrophysicist. And I appreciate that because if you've read any of the history of astronomy, there are a lot of women, whether it was Vera Rubin or Annie Jump Cannon or various others who did a lot of work that contributed to our current understanding, and yet until the last few decades really didn't get any kind of credit. Their male supervisors and stuff ended up. So it's interesting that they've chosen to name this one after her because she did a lot of work, of course, on galactic rotation many
Oh,
years
absolutely. She's
ago.
one of the
So
main reasons we think we know dark matter exists because of all her studies of different galactic light curves and stuff like that.
yeah, and it's like I said, it's nice to see that some of these female astronomers are now getting recognition that they didn't get while they were actually working,
Right.
right?
Yeah,
So,
yeah, and I also did so something I didn't know about her until I started looking into it was that her PhD thesis um, was actually talking about how galaxies prefer to cluster together instead of being randomly distributed in the universe, and that was something that was like no one really believed her, kind of said this is crazy, and then no one did anything that about that for another 20 years until telescopes got a bit better, and maybe a male published a paper about it, and they're like, oh yeah, galaxies do prefer to cluster together. Crazy. And it's just like, oh my goodness.
it was a symptom of the times. I'm glad I don't
Yes.
live then, but
Right.
it's nice to see that some of those historical records are being I don't exactly say corrected because a lot of the men involved did contribute, but that I think the lead, they're now recognizing who did the bulk of the work on a
Right.
lot of these things, whether it was Vera Rubin, whether it was Janny Jump Cannon, whether it was Henrietta Leavitt, whether it was, a number of other ones. I think prior to these guys, the only female astronomer who really got a lot of credit was Caroline Herschel, and that's mostly because of her brother and her nephew.
Right. Yeah.
She was just part of that family, so she actually got recognized, which is very unusual for the day, but quite interesting. So it's like I said, this telescope's got all kinds of interesting links and possibilities, and who knows what they'll be talking about, for discoveries it has made a year from now. Maybe in 18 months, some of us will be back saying, "Oh, look, we actually found planet
Right.
10
Yeah.
or
We
8
should
and
do
a half."
another podcast in the year where or whenever Planet Nine gets announced and just like, oh my goodness, you believe what we said? What do we know about anything?
Yeah, it's like I said, this whole Planet Nine thing has been going on really since I guess the Lowell Observatory came into existence. Because once they
Right.
found Neptune, they thought there were still other gravitational perturbations. There had to be one other one out there. And I mean, Planet X is one of the major targets for the Lowell Observatory, and that's how Pluto was found.
Hmm.
No, it's not the one that it's
It's
not
not
what
the
they
one
thought it
though.
was.
Yeah. Well,
But
speaking of like missing things and Vera Rubin, like if you think about how like, back to Rubin and maybe one of the dark matter predecessors, Fritz Zwicky, like back in their time, we kind of thought everything we could see, the baryonic matter, is all there was. And then, let the Zwicky and Rubin come along, and then, oh, actually, that's only about 5% of the universe. There's all this dark matter, dark energy, there's this stuff we can't see, that is still affecting the universe. And so it's almost like Planet Nine, but on a on a
on a
bigger
much bigger
scale.
scale, yeah. But I think the thing though that should be clarified is dark matter doesn't mean it's some kind of like antimatter or something. It may be a different kind of particle, but it's still matter. It's just it doesn't produce any kind of light that we can
Yeah.
observe through a telescope, which is why they call it dark matter, which is why you have to be a little bit careful um, I think some people say, well, like, oh, is it like antimatter or something? I say, no, no, no. We only
Mm.
call it dark because we can't actually see it.
Right?
It's just
Yeah, and
it's
which
just a
which
name, right? It's
yeah,
just a description. What exactly it is, we don't know.
it's
Uh,
frustrating that dark energy is also called dark. Because I think a
yeah,
lot of people think they're connected somehow, but it's also just a something we can't see.
yeah. So it's not something like weird in Star Wars or, something like that. It's just because we can't see it. It's very
Yeah.
simple. I
Right.
think that confuses people sometimes. So I try to always like, okay, well, it's this is why we have it,
Yeah.
right?
One thing I like to say is like, so it's something that we've ruled out, but for a while there's this idea that dark matter was just a whole bunch of black holes,
Yeah. Or
right?
possibly a bunch of brown dwarves or something
Yeah,
are
so
kicking
and
around,
that
right?
gives you something physical that okay, I can't see black holes or brown dwarfs are too faint, but they're still gravitationally affecting things.
Yeah.
Now again, we've ruled out that there's just no way there's that many black holes out there to account for all the dark matter we think there is. But it gives you an idea of it's not something science fiction-y or something, not necessarily something extremely exotic.
Yeah.
Um, it could still be yes some dark particle or some cool particle, but it's not it's not antimatter or something
I know. And
something
I think I
magical.
think I think because we have so much of a, I know, Star Wars, Star Trek world, we tend to go to those people tend
Right,
to go to those kind of exotics. It's like, no, the universe is much more boring than that in some ways.
right.
It's like, yeah.
Yeah, yeah, it'd be cool if half the stuff we discovered was, oh, that's aliens. Definitely aliens. I would love that.
Yeah, no such luck.
I had a blip in my star's brightness. It must have been a starship going by. Oh no, there's just dust on your detector.
No, it's just another Starlink
Or
satellite
just
away.
another Starlink satellite. Right. Absolutely.
And speaking about observatories, I think you were the one who pulled up about the Greenwich Observatory.
Oh yeah. So yeah, I was looking it was literally just oh yeah, no, June 22nd was like yesterday. The 350th anniversary of the Royal Observatory of Greenwich. um, which is kind of crazy. And so this is the observatory that when it was first launched, it was tasked with the idea of solving this longitude problem, which we kind of already talked about. Essentially, navigating across the globe at sea, it was not very accurate back then, especially when you're traveling east-west. It was a little easier to go north-south because you had the North Star, but east-west travel was much less accurate. And so it would help the people on the sea if there's precise timekeeping capabilities that didn't rely on external factors. And so this at the observatory there, they did all these very detailed, meticulous observations of the moon and the stars, and really tried to come up with ways to produce these star charts or celestial tables that made navigation much easier.
Yeah.
And then a little later, 100 or so years later, they also came up with the Greenwich time ball. So this is this big signal on the roof that would drop at a certain time, and then all the ships in the nearby bay could set their clock, essentially, so they'd know exactly what time it was.
Yeah.
Uh, and so this is why we have Greenwich Mean Time. That's where that stems from. That's why the prime meridian just 0 degrees runs right through Greenwich. It kind of has a pretty historical impact that has stuck around to this day, even though it's probably not that active in astronomy anymore. I'm guessing
No.
it's probably getting hit with plenty of light pollution too.
Oh, yeah, I mean, you're right in the middle of London at this point.
It's
It was
probably
on
for the
the
best.
outskirts. It was on the outskirts when it was built, but not
Right?
anymore, right?
Not
But
anymore.
it's like I said, if you read the history of the Greenwich Observatory, it's fascinating because it was so involved in sort of the quest for accurate navigation because it was a huge issue for, all these European seafaring powers, whether it was the British, whether it was the French, the Spanish, the Portuguese, the Dutch, they were all out there sort of exploring the world and staking their claims. And it was very easy to get lost because you
Yeah.
couldn't figure out like how far you'd gone and you'd try, and there were all kinds of like strange methods to sort of estimate how far you were going. um but it came down to star observations and timekeeping, right?
Right? Yeah.
So,
Yes. A very like a like practical hands-on application, like direct hands-on of astronomy, you know, there's this immediate like, hey, we figured this out. Now this is literally gonna change lives, change countries or cultures' fortunes.
oh yeah,
Uh, you know,
and
it's
literally save lives because people could navigate more
right. Yeah.
accurately and not get lost at sea if they went out of sight of land for any length of time, right?
Yeah.
I still remember the other funny one about it is when they started doing this, they also got more accurate land measurements, right? Because you could figure out distance and longitude on land. And I think there was a quote, it may be a bit urban legend, but quote by the French king going, the astronomers have taken away more land from France because they had vastly overestimated the size of the country. The astronomers
Oh,
have taken away more land from France than anybody else, or than the English ever did, or someone else ever did.
oh, that's hilarious.
Yeah, because you couldn't really measure land distances very accurately either if you don't sort of know latitude and longitude and navigation and all this kind of stuff. But all of a sudden, when you can measure this, you can also, to some extent, measure distance more accurately too.
Right. I never would have thought of that, but it's absolutely right. Yeah. Once you know the change in coordinates from 2 points, that distance, and that's probably way more accurate than
Yeah,
other ways of doing it at the time.
yeah.
That's
And there
hilarious.
was quite a bit of competition between Greenwich and the Paris Observatory at that time to be the first one to get the observations and figure this out. So it was just that, the English won out at that sort of race for longitude or navigation.
Hmm,
So, but
cool. Wow. I don't think any of my published works have saved lives. Trying to think, but
not many astronomy things do anymore. They're
no, I
like,
don't
okay,
think
well,
so.
it's kind of fascinating, but
Yeah. It's cool, but yeah.
it's
No, I haven't
cool.
saved a life, I
But
don't
yeah, I'm
think.
not
But
sure how
yeah, no,
practical it
it's
is
just
to be
amazing
honest.
how it's progressed over the years.
Oh yeah. I mean, if you think about it, in this episode, we've gone from Stonehenge, which are the simplest of observations, the very basic observations in the start of the sky, to Vera
Right.
Rubin, where you have the most recent telescope that's, basically observing the entire night sky and recording it every night.
Yeah.
It's just As like I said, I'm curious to see what discoveries come out of the Vera Rubin over the first year or so. I mean, if you look at what James Webb has given us in the last, year or well, year and more, although it takes a while for the data to get analyzed and everything, it'll be cool to see um what happens over the next, year with Vera Rubin. Right?
Oh yeah.
Some of that southern hemisphere stuff is just not nearly as well observed as it ever has been, right?
Oh, oh no.
So,
I think we're getting a little spoiled. Yeah, but like you said, between the Webb Space Telescope and Gaia, between the exoplanet telescopes, Kepler, and the ones upcoming test, like I just think it's an awesome time to be about astronomy. There's so many different spacecraft and observatories that are just primed and ready to go, and I think the next few years are going to be really exciting.
yeah. And yet the technology of Stonehenge probably would have been the equivalent to people in the day.
Right?
You think about it, right? We think, oh, it's fascinating, it's primitive, blah, blah, blah. To the people of the day, it was Vera Rubin or James Webb or, you know, whichever one it happened, whatever is the
Yeah.
more recent one. Okay.
Yeah.
So,
Yeah, no, that's a good way to put it. That we keep having these moments, I guess, essentially. And yeah, it's kind of just cool being at the frontier of it.
but it's nice to remember some of the ones in the past.
Right? Yeah, yeah. Well, I think when I even just not that long ago, but I just remember when I was a kid and Hubble was first launched, that was such a huge deal.
I
Uh,
remember the first launch of the space shuttle. Okay, I'm going back even further.
yeah, well that was
So we've only got a few minutes left. Is there anything in the night sky right now you think might be really worth observing, assuming we don't get a lot of rain and haze over the next few days?
I don't know. So I got one of these little sea star telescopes the other
Oh
like a
yeah.
week or two ago, and it's been very cloudy almost every night since I've got it. And then the only couple clear nights we had, I fell asleep right after my kids went to bed. So I've taken a few pictures of the sun, but I haven't actually gotten out at night to check anything. So yeah, I don't know. Maybe ask me in a few years when my kids are older and I actually
Yeah,
stay up.
mine are fortunately old enough now that I don't have to worry about that. But I still find I'm a morning person, so I'm more likely to be up at like 5 a.m. to see what's up early in the
Oh,
morning than later in the day. Although the one thing that is starting to become visible right now is the summer triangle. By about 11, 12 at night, it's well up into the sky.
okay,
There's not a lot of planets out right now. Mars is setting just after sunset. I don't think Saturn comes up until quite late. It's
right,
kind of a bit of a boring summer for planetary observation this year, unfortunately. Uh,
right, yeah,
but yeah, the summer triangle's just coming up. I think um, they had I think they were doing Arcturus and Vega and Polaris and a couple of and maybe one other ones that they were doing in the live viewing if you're following along on YouTube, but those are all sort of good ones in the sky right
right.
now. Um, but yeah, the weather isn't looking great for the next week. So maybe next
Oh,
maybe the next podcast they'll have some great targets they can suggest. So
yeah, that'd be fun. But no, it hasn't been. Yeah, the weather just
hasn't
hasn't
been the
cooperated.
greatest. And we're really hoping for a good sort of reasonably clear and not brutally hot day so the Astro Fair can take place sometime in the next few days. So hopefully, fingers crossed, it'll happen soon.
Yeah, yeah, fingers crossed. I think it's admirable and ambitious that the observatory is doing one of these. Let's wait for a clear night. We're gonna do it right. So, a lot of these astronomy events, you kind of roll the dice, and you're like, I'm just gonna make
Oh
it this
yeah.
day. If the weather's good, great. If not, we'll have some indoor activities to do. But I think it's cool that we're trying to do something that says we're gonna wait till it's right, and we're gonna do it up as best we can. So fingers crossed over the next few days we have something that works out.
So we're getting to the end. So welcome. So thank you everybody for joining us. Whether you're listening live or whether you're listening to this podcast at a later time. You have been listening to York Universe, the astronomy and astrophysics program written and presented by the student, faculty, alumni, and friends of York University. The hosts this evening have been myself, Mary Armour, and Jeremy Webb, who are both professors at York University. If you're interested in finding out more about the observatory, you can always connect with them at the Instagram with the handle at York U Observatory. The Allan I. Carswell OBS is the Facebook page. And of course, most importantly, you have the website, which has links to all of these things, which can be found at www.yorku.ca/science/observatory. So thank you to all our, if you have been listening on YouTube, thank you to all our crew for some great images and pictures from the telescope tonight. Thank you for tuning into York Universe. Clear skies and have a good night.
Thanks, everyone.